Hello students. Today we are going to learn about various forms of equations of a line. Okay. So there are various forms. Now first one is if you have a straight line which is parallel to either x-axis or a y-axis. Okay. So the line is parallel to axis. So if it is parallel to x-axis, okay, and if it is parallel to y-axis. So the line is parallel to x-axis. So it is like this. Okay. Now this passes through the point. This point will be what? This is your x-axis. Y. This point will be some x point is not there. So 0 comma, say this point is B. Okay. This distance is B. 0 comma B. Okay. So the equation of this line is y equal to b. This is the equation. Okay. Now if you have x, so the line is parallel to y-axis. Then this point is a comma 0. Okay. So x equal to a is the equation of the line which is parallel to y-axis. So they are also called horizontal and vertical lines. Next is the line point slope form or slope point form. Point slope form. Point slope form. So we need a point and a slope. Suppose we have a point x1, y1 and slope as m. Okay. So slope is given by some say this is our line. Okay. 2 points are there. One I'm taking x comma y, one I'm taking x1, y1. So x and y we don't know. Okay, this is unknown point and this is given. So we can write slope as y minus y1 upon x minus x1. So this becomes m x minus x1 equal to y minus y1. So this is another equation, that is point slope form. Okay. Then third one is 2-point form. So as the name gives you 2 points, 2-point form. So here 2 points are there, say x1, y1 and x2, y2. So there is a point, because this is A and B, there is a point P which is x comma y, which is unknown. Okay. So how the slope, so distance from this to this is equal to distance from this to this, because all are on the same line. Okay, that is they are collinear. So I can take the slope of both the lines to be equal. So y minus y1 upon x minus x1 equal to the second one y2 minus y1 upon x2 minus x1. Okay. So this you can use, or you can write y minus y1 equal to x minus x1 y2 minus y1 upon x2 minus x1. So you don't need to by heart these forms. Okay. So you know that if 2 points are there, then you have to take the slopes of both the lines to be equal, and you have to take one unknown point in between them. Okay, directly you can write the equation. Next question. Next is intercept form. Now, what do you mean by intercept? So we have two intercepts, x-intercept and y-intercept. So whenever you have a line and it touches either of the axis, that is x-axis or the y-axis, okay, that point, if it is touching x-axis, then that point becomes your x-intercept, and this is your y-intercept. Okay, so this point is what? 0 comma y. Okay, or you can write 0 comma b, and here this is a comma 0. Okay? So the intercept, uh, in intercept you have to make use of the these points. Okay, and there is a point in between. Okay, so basically this is a 2-point form only. Okay, there is a point in between. So you have to take this distance, that is this slope, equal to this slope. Okay, so I'll write y minus b upon x minus 0 is equal to 0 minus y upon a minus x. Okay, so this is your minus y, this is x. You can write y minus b a minus x equal to minus xy. Okay, or you can write this as multiplying, you will get ay minus xy minus ab plus xb equal to minus x. So this xy will come here and gets cancelled. So you'll get ay plus xb equal to ab. Okay. Now dividing by ab, so you'll get x upon a plus y upon b equal to 1. So this is your slope intercept form. Okay, where a and b are the slopes. Where A and B are the intercepts. So this is x-intercept, this is y-intercept. Okay. So we saw intercept form only. Okay, there is one more form, that is slope intercept. That is, you have a slope and an intercept, any of the intercept. Suppose I have x-intercept, that is a comma 0, and there is another in which there is a slope and y-intercept. Okay. So for a x-intercept, the equation becomes y minus y1. You have to make use of slope point form. So m into x minus a. Okay. Here y is 0, so y equal to m x minus a. This is for x-intercept. Okay. Here y minus y1 equal to m x minus x1. So y1 is our b. So y minus b equal to mx. Okay. So this is for y-intercept. Okay. Next form is normal form. or perpendicular form. Okay. So I'm going to derive this. Yes. Suppose you have a line, okay, which is perpendicular here. Just draw perpendicular here. N O and this is, then there is a line which is perpendicular from N to x-axis. Okay. This is Q 0, 0. Coordinates of this is this point y and this is x. So this point I'm taking N. So x coordinate is OM, that is this distance, and y coordinate is this point is ON. No, y coordinate is MN. This is ON, but ON is same as MN, so I will take it as MN. Okay. This angle is theta. This angle is obviously 180 minus theta. Okay. This angle I am taking alpha. Okay. So let's see, ON is the perpendicular, okay, drawn to this line. This is L. So this distance is P. Suppose this distance is P. This is a perpendicular. Okay. Take triangle ONM. That is ONM. Okay. This is a 90-degree triangle. Here alpha is there. Okay. So if you take cos alpha adjacent OM upon opposite MN. Okay. And we know the distance ON adjacent upon hypotenuse. Sorry. So, and ON we are taking as P. Okay. So from this you will get OM is equal to P cos alpha. Okay. Same way you have to write for sin alpha. Sin alpha opposite upon hypotenuse. So Mn upon P. So you will get Mn is equal to P sin alpha. Okay. So we got this coordinates, that is OM and MN, in terms of P cos alpha and P sin alpha. Okay. Okay. Now consider triangle ONQ. ONQ. Okay. That is also a 90-degree triangle. Triangle ONQ. So here I am applying triangle sum property. So alpha plus this angle, that is 180 minus theta plus 90. is equal to 180. So this 180, this 180 cancels. So alpha minus theta is 90 degree. Okay. So from this theta is alpha minus 90 degree. Alpha plus 90. So, alpha minus theta is 90. Yeah, theta is alpha plus 90. So if you take slope, because theta we want for slope, tan theta. So this is tan of 90 plus theta, 90 plus alpha. Okay. This is minus 90. Okay. That's why it is positive here. Here you have to use trigonometry again. 90 plus alpha. So it is in the third quadrant. Third quadrant. So we are adding pi by 2 to the angle. Okay. So pi by 2 means this tan becomes cot. Okay. And what about the sign? Tan is negative here. So sign is negative. Okay. Now we have the slope and the point. This is our point and this is our slope. M is equal to minus cot alpha. Okay. So let's write the slope point form. Okay. So y minus y1. y1 is our p sine alpha. Equal to slope into x minus x1 is p cos alpha. Okay. This thing will give you the normal form. Okay. So this is y minus p sine alpha equal to cot alpha is cos alpha upon sine alpha. Okay. Multiplying, we get this, you multiply here. So y sine alpha minus p sine square alpha equal to minus x cos alpha plus p cos square alpha. Okay. So when you take this thing here, so you'll get y sine alpha plus x cos alpha equal to p cos square alpha plus p sine square alpha. And we know that if you take p common, this will be cos square alpha plus sine square alpha, that is 1. So this comes to x cos alpha plus y sine alpha equal to p. This is the normal form. Okay. Where p is the perpendicular distance, that is this distance of the line, and alpha is the angle which is made by this line to this line. Okay. So then we'll get the equation.